Have you ever wondered what really happens before a programmer writes even one line of code for your favorite app? I'll tell you, it is not magic. It is all about planning. And that secret first step? Well, that's what makes the difference between a frustrating mess and a piece of software that just works. So, let's dive into the programmer's blueprint.
Think about it like this. You would never, ever start building a house without a really detailed blueprint, right? Of course not. You've got to know where the walls go, where the doors are, how the plumbing connects. It's the only way you're going to end up with a house instead of just a big pile of wood.
Well, here's the thing, it's not. Trying to write a program without a plan is exactly like building that house without a blueprint. You're just going to waste time, you'll run into all these dead ends, and the final program, it probably won't work the way you want it to. So let's take a look at what that blueprint actually is for code.
Okay, so this first part is all about the why and the what. Before a programmer even starts thinking about a specific language, like Python or Java, or any of the nitty-gritty details, they have to create a solid plan. This is the foundation. Everything else is built on top of it.
So why is this planning stage so critical? Well, first, it forces you to really truly understand the problem you're trying to solve. You can't fake it. Second, it makes sure all your instructions are in the correct logical order. Get the sequence wrong and the whole thing just falls apart. And finally, a good plan is your ticket to writing code that's not only efficient, but more importantly, correct. So this plan, or blueprint we keep talking about, it actually has an official name. And it's a word you've probably heard thrown around a lot: an algorithm.
And that's really all it is. At its core, an algorithm is just a recipe. It's a precise, step-by-step set of instructions designed to solve one specific problem. And here's the crucial part. It's all about the logic of the solution, totally separate from any specific programming language. You design the algorithm first, then you go and translate that into code.
In this comparison just nails it. On the left, you've got the plan for a physical building. On the right, you've got the plan for a digital one. But they both serve the exact same purpose: to be a clear, unambiguous guide before you start building anything. Now hold on, because not just any list of instructions gets to be called an algorithm. To earn that title, it has to follow 3 pretty strict rules. First, every single step has to be crystal clear, no room for guessing. Second, it can't run forever. It has to have a definite endpoint. And third, and this is the big one, when it does end, it has to have actually solved the problem correctly.
Okay, that is enough theory for now. Let's see how this stuff actually works in practice. We're going to design a really simple algorithm to solve a common classroom problem.
So, I want you to imagine you're a teacher, and you've got this big stack of exams in front of you. You need a fast, totally reliable way to pull some specific data out of that stack.
All right, here's our mission. We've got 50 student grades, and our goal is to figure out exactly how many of those students scored above a 70. Seems simple enough, right? But how would we write a precise recipe that a computer could follow, no questions asked?
Okay, here's our step-by-step solution. Step 1. We start by setting our counters to 0. Easy. Step 2. We grab the first student's grade. Step 3. We check. Is that grade greater than 70? If the answer is yes, we jump to Step 4 and add 1 to our high scorers count. Now, Step 5 is where the magic happens. It's the loop. We check if we've gone through all 50 students. If we haven't, we go right back to Step 2 for the next student and repeat the process. And once we've finally checked all 50, we can move to Step 6 and just print out our final total.
And there you have it. See? It's precise, it has a definite end, and it absolutely gets the job done. It perfectly follows our 3 rules. That, right there, is a solid algorithm.
But here's where we take it to the next level. Just because an algorithm works, that doesn't automatically mean it's a good one. You see, there can be tons of different recipes to solve the same problem, and trust me, some are way, way better than others.
This is a question that programmers are constantly asking themselves. How do we measure the quality of our plan? How do we know if our solution is elegant and efficient, or if it's just clumsy and super slow?
Well, there are 3 key qualities we're always looking for. First, the time requirement. How fast is it? A really great algorithm gets the job done quickly. Second, accuracy. Does it give the right answer 100% of the time, even if you throw weird or unexpected data at it? And third, generality. Can it handle a whole range of different inputs, or does it only work for one very, very specific case?
To make this really concrete, just think about the GPS on your phone.
A poor algorithm might sit there spinning for minutes just trying to calculate your route, but a good algorithm, the kind your phone actually uses, can process millions of pieces of information and give you the best path in literally a fraction of a second. That is the power of an efficient plan.
And this isn't just some academic exercise. The entire digital world you interact with every single day is built on this exact foundation. The way your social media feed is sorted, how a search engine finds what you're looking for, how your GPS navigates you through traffic. It is all powered by carefully planned algorithms.
So the thing to remember is that the code itself is just the final step. The real work, the really tough intellectual part, is in the planning. That's what transforms a simple list of instructions into a powerful, efficient solution that can run all the technology we rely on every day.
And that leaves us with one final thought to chew on. Think about your own life, your morning routine, the way you make coffee, the route you take to work. What's a process that you follow every day that you could break down into the precise, finite steps of an algorithm? You're probably using this kind of logic and planning way more than you think.